Welcome back. Today we're going to be looking at collections in Python. And collections aren't a list of stamps or shells or other things that people collect. It is a set of containers that you can use in Python. And they're quite specific containers that you tend not to use, which is why they're not available without importing. And the first one is a counter, which isn't the thing that you play board games with. Instead, it's a kind of histogram thing, and you can see this is one from Seaborn. We're going to start by importing. You can see we've got a counter and a deck, which we'll look at later, and then a couple of other imports. You don't need to install it with pip because it's built into the Python library. So we start with this list of colors, and what we're going to do is we're going to say for each color in our colors, we just increment the colors. And you see that our counter ends up with red having 3, because there are 3 reds in this list, 2 for blue, and 1 for green. Although alternatively, we can just initialize it with the list, and that's a lot easier. The other thing we're going to do is we're going to go to this page, which contains Harry Potter book, The Philosopher's Stone, and we just download it. And then here we find all the words using regex. And to show you the first 10 words, it's the boy who lived, and then Mr. and Mrs. Dursley of number. And so you can see that it's worked, and it's converted them all to lowercase. So they're going to create a counter for all these words and find the 10 most common words. And you'll be pleased to know that Harry is up there, especially given the book is about Harry Potter. There also is the total function, which we expect to give us the same as the length of the list, and fortunately that has worked. But interestingly, if we look for pool, the word pool does not appear in the counter. You can also do some interesting operations with the counter. So we create 2, one for each of these lists, and you can see, the first one, it's got all these different values, and the second one, just got one of each. So we can add them together, and it just adds the numbers, fairly simple. But we can then subtract them, and you can see now, most numbers have decreased, but it's gotten rid of G and H, which only appear once in the first list. And so their value is now 0, because when you subtract, it gets rid of negative or 0 values. You can AND them, which takes the lowest of each one, and you can OR them, which takes the highest of each one. So you see they're subtly different. So the counter is very useful, seeing how many times, for example, letters appear, finding the most frequent, and it's a useful one to know. But the next thing is the deck, which is short for a double-ended queue. And as you can see in this picture, queues are very important. They have a front and a back, although in Python they're called a left and a right, and you can pop or you can push, but in Python push is append. So you can pop to left, append to left, or you can pop or append. So we've already imported our deck earlier, and so we just create this deck from GHI. We loop through it, and we see the letters are GHI in that order. We can append J to the right and F to the left, and you see now our deck looks like this list. And it does look a lot like a list, but it is quite useful to know that it's a deck, because one thing we can then do is remove from either side, and this unsurprisingly brings back to just before we appended it. We can index using positive and negative indices, so from either side, and the first thing, index 0 is D, and the last thing, index -1, is an I. We can convert it into a list, reverse it, and then convert it into a list. We can check if something exists, so you can see that H is in our deck. We can extend it, which is quite useful because we can just add another iterable, and you see it adds J, K, and L. We can then clear it if we don't want anything else, and if we try popping from our empty deck, you see we get an error, because it's empty. So you can check if it's empty and then try popping. We can extend it to the left. However, you can see it's put everything in backwards, because it's first done A, and then B, and then C. But we have added to the left. Then there's this interesting rotate function, which allows you to take everything and in this case slide it to the left because it's negative. So A has gone here, B has gone from left to C, and C has gone all the way around because it's rotate in the position of A. We can rotate forwards, which actually does the same thing, where the A has gone round, the B has gone right to, and the C has gone right to as well, or we've put a positive number in. But it's nice to have a look at some practical applications of a deck because it does seem like quite a strange data structure. Whereas the counter, you can immediately see where you might need to count things. The deck is less obvious. So the first thing is this tail example. So as it says here, it returns the last n lines of a file. And so if we get the Philosopher's Stone again, we can see the last 10 lines are the page numbers. And then here it says, "Oh, I will," said Harry. And they were surprised at the grin that was spreading over his face. And you can see these are the last 10 lines of this file. And most of them are empty, but it has worked. There's also this called a round robin. So if you imagine you have a processor and you're scheduling, so you take the first one of each iterator and then you keep looping through them. So to explain with an example, what we do is we say we take A, we take D, we take E, and we do one block, and then we go back, and then we've done A, so we do B. This is empty, so we ignore it, and then we do F. Then we go around again, and we say we take C. This is already empty, and this is empty, and then everything's finished. And you can see it does that by turning each of them into a deck. You can see it does that by putting each of them into a deck and then rotating it while doing each one. And then when they're no longer got anything left, we just get rid of it. But the most obvious and I think nicest application of a deck is a moving average. And there are slightly more sophisticated sliding window algorithms you can use, but we just convert it into an iterator. We take this slice so that we only get the start, and then we put a 0 to the left. And the reason we do this is so that the sum starts off being 0. We then take the sum of our current deck and we repeatedly add each element and get rid of the element that was last in the deck and so slides out of our moving average. And then we just return the sum divided by the number of elements to get the average. And you can see it's gone along, it said 40, 30, 50, average is 40, 30, 50, 46, average is 42, and so on all the way through to give us the moving average with the n value of 3 of this list. So you can see a deck is quite a nice data structure, one you probably might not have seen before, but is really useful to use. So hopefully you've enjoyed this video, you use decks and counters in your future projects, and I'll see you again same time next week. Till then.